leading a development team there. So he has lots of experience. And so please welcome Philip to the stage.
Thank you. Thank you everyone for this warm welcome. I knew when the talk will be the first after lunch, I will have a hard time to keep you awake, so I will do my best. But today I want to talk about a real use case I realized when I was this lead of development at Swisscom. We did this for a bigger bank, and I tried to reproduce that using only Atlas tools, and that's exactly what I want to show you today. And you see this little QR code here on the top. I have a YouTube channel on top of that, so everything you see here very condensed in 30 minutes. You can see in more detail visiting my YouTube channel. No worries, keep your mobile phones in your hands. There will be QR codes, as you know already, to rate this session afterwards, and I will show you this QR code afterwards again. All right, so what I want to show you in the next 25 minutes or so is how to use Atlas as a one-stop solution for, of course, persisting data, or for creating APIs out of the box, especially GraphQL APIs, which are very, very flexible on top of that, in combination with functions and triggers. And I want to show you how you can combine that with the Atlas Search feature, which makes it much more powerful on top as well. And of course, you can use Atlas to host your single-page web application as well. So there's a one-stop solution to do it all on top of Atlas. And it's not only these features I show you here, it's secure by default. So I will show you how to implement user authentication and authorization, which is very important to use this platform securely, and how it scales with the needs of your users. So the worst thing that can happen to you as a developer is you create a fine app, it works perfectly, and users love it. And then you need to do night shifts to scale your application background because you hadn't that in mind in the first place. So here you get a platform which scales automatically with the needs of your users without any intervention. And it does that on demand. That's very, very important. So really quick reaction on user behavior. And in the end, it scales also globally. You can start, for example, here in Germany, or you can start wherever you want in a small local installation, and then you can grow globally with the success of your application. Because every developer dreams of building once in his lifetime an application used by the whole world, I guess. At least I do. Okay, but why is this so important to have such a platform under the hood? Why is this so important? I want to point you to a paper published by Stripe in the year 2018. And they said by asking, so this comes out of a survey of thousands of executives, they came to the conclusion that access to developers is actually harder than access to money. So bringing developers up to speed, make them more productive, and so on and so forth, is a much better solution than getting just access to money. And that's why maximizing the developer velocity, so making developers fast, is really key here. And the analysis brought an important number. I want to point to that 42%, so almost half of the time developers spend by just fixing bad code, scaling, doing stuff which doesn't add any new feature to your application. Probably you know that, huh? All developers in the room probably know that out of their heart. You want to bring this new feature out, but you get stuck by, you have hazels here and stuff like there, but you want to bring this new feature out, and you're not capable. Okay, what you see here is the Atlas App Services Platform, or the Atlas Developer Data Platform, as we call it, with all their features included, and I will take you on a journey through these features here in the round circles. We had other talks about the other features. We want to go through Atlas as database, which scales. We want to go through how to implement search here, and then how to create out of the box a GraphQL API and implement this in a web application. So let's see how all this works together. And I brought to you a little diagram which brings you a little bit into the movie what I'm thinking of. So let's take the database on the bottom, of course, then attach Atlas Search to it, sync it, create your search index that you get search capabilities. And on top of that, we add the Atlas App Services. And I take out of the Atlas App Services only triggers, functions, authentication, authorization, and the GraphQL feature. And then I attach a desktop web application that runs in a browser. It's a React application, React.js application, and I use a web component, a very famous web component called AG-Grid. It's a really featureful grid component. Wanted to show you how to implement your own components, how you can adapt the Atlas App Service features to just use ready components you already love and like. And then, to make this a little more interactive on top, I have external events hitting the database as well. So we're updating the database under the hood, and let's see how the web application will react in real time to these updates on the database. And just a little announcement on top of that, right after my talk, there will be Andrew Myers coming here, talking how to attach a React Native implemented mobile application to kind of this setup as well. So we will see how this interacts with the device sync as well on top of that. Okay, let's dig in. I take you to the journey and will show you first of all how does the data set looks like. So this is a fictional data set. It could be a bank, could be a shop, could be anything. So you have customers, they have names, they have addresses, they have some CRM information, and they have accounts, and these accounts obviously have balances. You have fixed fields and you have pre-calculated fields. For example, you see here age and total balance. These are typical pre-calculated fields. We pre-calculate them out of the birth date, for example, or out of the single balances into the accounts using functions and triggers. The front end then looks like a typical grid. Surprise, surprise. It's just a grid, but you see this grid has a search bar on top. I can search. And I can play around with the data in my dataset by just using this grid. Okay, let's go to the backend. How does the backend looks like? So you will find the Atlas App Services by just clicking here on the tab Atlas App Services, and then you will end up on this page here where you can create your serverless apps. And the first thing you need to do is you create a schema. So why the hell do you need to create a schema? We are in the schemaless or flexible schema database realm here. Why to create a schema? That's because GraphQL needs a schema. That's an important thing. If you have just standard JSON REST APIs, there is no contract between backend and front end. And you need a contract that the front-end team can work on your APIs by exactly knowing how it behaves. And therefore, we need to create a schema. And you wonder why or how difficult is it to create a schema here. And I created a little looping video, and I needed to loop it because it goes so fast that you need to see it multiple times. So first, you just select your collection. This collection is called Customer Single View here. Then you scan for 500 random documents inside of it, and then it creates a JSON schema by just scanning the documents in your collection. And that's it. Of course, this JSON schema ends up in an editor. You can edit it by hand, enhance it, do stuff like that, but the heavy typing work is just done for you. You have the schema, and now GraphQL would be capable, or we are capable to translate this JSON schema into a GraphQL schema out of the box. Next step, you need to enable authentication. And yeah, guess what? Authentication is under the Authentication tab, of course. You go there, and then again, this video will loop again indefinitely. You have multiple authentication providers out of the box available, and you just enable them. You can enable just one, you can enable multiples. In this case, I enable the email password authentication. But you have, as you can see, Facebook, Google, Apple authentication out of the box available. You can implement with your own JIT tokens, or you can implement your whole separate authentication logic on top of that. Just to mention that, we don't leave you alone with that. For example, email password, as you can see, there are functions available for self-registration, password resetting, stuff like that, out of the box available as well. Okay, now your user is authenticated, you know who this user is. Next thing what you need to do, you need to enter rules. What can the user do with its data? And therefore we have under data access these rules. And for the rules, it's as easy as before. You select your collection. You can add a predefined access rule. For example, here we give read and write access, no, read all access to everyone. That could be one rule, but you can stack rules as well on top of each other. So more complex rules like this one. Here we can see that the user will be capable to edit his street and city if he's the owner of the record, for example. So if the user ID matches with the owner ID in your document, then on these two fields you give write access. And you can stack these rules together and they will be read from the upside down, top to the bottom, from the rules engine. And that's the only point where you have to worry about access security. Each JavaScript function you write afterwards, each access to the GraphQL API will run through these rules over here. You don't have to worry anymore in your application about that. Okay, now we're ready to talk about GraphQL. Now, how do you get from this schema, access rules, authentication to your GraphQL API? Yeah, you just click on the GraphQL tab here. And then you get your GraphQL schema generated out of the box, out of this schema we just generated before by scanning your data. And you get lots of out-of-the-box functionality already implemented. For example, you can see here we have a limit. We have some query parameters like greater than, lower than, stuff like that. So it recognizes, is it a number, is it a text, some stuff like that. And you have sorting out of the box available as well. And as if you can see, the name of my collection before was customer single view. It was a singular name. Here it's called customer single view. So it creates singular and plural. So they get back one document or multiple documents. That's out of the box available. But that's not enough, because what we want to implement is kind of an infinite scrolling behavior of this AG-grid component. Now you can see here AG-grid is scrolling. And AG-grid has an implemented feature where it asks for a specific window of data, start row and end row. It gives us back start row and end row, and it expects on the bottom that we give him the total numbers of results we want to display, so that it can pre-allocate the right amount of lines to load. But it loads, you see it in the browser, in the browser analytics, network analytics, it loads 20 records by 20 records, it preloads, and you get an infinite scrolling behavior without having everything in your browser. So what does AG-grid send us here? As I said, it sends a start row, it sends an end row, and it expects to have the data in a rows array, and this last row must have the number of total rows you would like to display. So how to do that? Therefore, you need a custom resolver, we call. So now you can enhance your already existing generated GraphQL schema by implementing here custom resolvers. And you start, obviously, by giving this a name. The next thing you will do, you need to define the parent type. We have query as top parent type, or mutation as well as top. Or you can implement single fields in the already existing schemas. And then you need to define a JSON schema for the input. In this case, we expect to have two integers coming in, start row and end row. And then you can hand that over to a custom written JavaScript function. And I will quickly show you how complex this JavaScript function will be. It looks like this. So 15 lines of code needed. So you get in the input parameters, for example, start row, end row, then you open a connection to your customer single view collection, and then you can start creating a aggregation pipeline. This aggregation pipeline, I use a facet, and this facet does two things. It gets back the rows I like, start row, end row, only these 20 rows, and it gets back in the same query, it gets back all records available in my collection by just counting it. Usually you would do 2 requests to a database to achieve that. Here you can do it in once. And then you just execute this aggregation pipeline, gives the result back, and that's it. Now, let's combine that with search, because infinite scrolling and pagination, yes, I know it sounds so simple. It's not so simple all the time, but let's make this more excited and combine that with Atlas Search. So what is Atlas Search? Atlas Search implements a lucene search engine to your data. So you have your MongoDB in place, and we spin up a second process on the same virtual machine, holding a lucene engine inside, and we start syncing the data in real time. And because this sits on the same virtual machine, synchronization is super fast. There's no network latency, it walks all through localhost inside. But you get on top for your application in the same API, in the same connection string, with the same access rules and so on and so forth, full lucene search capability on top of your MongoDB stored data. How easy is this to do that, or how hard it is? So let's go to your cluster, and then you have here this search tab. And under this search tab, you're able to create search indexes on collection level. So for every collection, you can create multiple search indexes, and I will quickly show you how such a search definition looks like. So you can see there is a visual and JSON editor available. I highly encourage you to use the visual editor to start with. It's really quite powerful, but if you go deeper, you will end up in the JSON editor and write some JSON like this. So this is a definition for a lucene search index on top of Atlas. As you can see, you pick the fields you want to have in this index, and for example here, we will have an autocomplete index on the first name, last name, and the address, so that my user can start typing on top and will find results in all these fields automatically. Yeah, let's see how this works. So what I implemented here is a so-called cross-field multi-match search, and you can see you start just typing, and the more precise your search term will be in case of words, the less records you will show. And again, watch this. So this is really not speed up video. This is real time on a small machine, but you get the count instantly on how many records or how many documents will be found by your search term. And on top of that, you get also fuzzy search as well. So for example, I type here the typical German last name Meyer, but it's written in so many different variations. You can see we will find it with epsilon, we'll find it with double I, with AI, and so on and so forth. So this is available as well, just out of the box by just creating how many lines of code? Just creating one more line of code. It's the line 7, where we just get this enhanced search stage. And what it does, it creates a search query on top of my data. And then I combine that with the facet we already had. But now, in the facet, I get the count out of the search meta. So I get really from the lucene engine back how many records it will find, and don't count every record. That makes it so super blazing fast. And what's inside this function, get enhanced search stage on line 7? It's just this one. We get in the search text, which is highlighted in blue color here. And I do just autocomplete search, for example, on the last name, first name, and on the country. And then I count the words and set the minimum should match to the number of words I have in my search text. And that leads exactly to this behavior. The more you type, the less results you have. That's what we know from most of applications. And I was really, really amazed how easy this was to implement, because I had to remember how hard it was without such a platform doing it before. Okay, I promised you I will make this a little bit more intense on top of that. So let's hit external events to the database. Let's update the database with external events and see what happens. So we're talking now about real-time updates using the App Services SDK. The Web SDK enables you to do that. And now watch closely. I have in the dark window is MongoDB Compass updating the balance of a single account, and I show in the browser the total balance of all accounts added together. So I let loop this video again. So watch closely when we hit this update button on the bottom right. You see instantly your browser updates. So what happens in the background? We have a database trigger watching for a change on the accounts. If there is a change on the accounts, we instantly update the total balance, and then we send this event out to the browser. And this is how development really gets fast, because this is usually very, very hard to implement. That's how you implement this. And this is browser code. Who is familiar here in the room with the MongoDB change streams? Have you worked with change streams already? One? Not so many? Two, three? Okay, this is MongoDB change streams, but this is actually running browser code here. So what we get here from our Web SDK, in my React app, I get the logged in user, I get a Mongo client instance. And then I attach to my customer single view collection, and then I get this iterator here on line 4. For every change in this collection, watch this collection here, filter, I only want to see update events. And I only want to see in the update events if they have the total balance field updated. And if they do so, so on line 10, we loop on every row the grid is just displaying, because only the grid in your browser knows what it's showing. Nobody else knows. We loop over all records just shown to the user in the grid and check, is an update there for this specific value, and then we update this instantly in the grid. And this works in real time, and it's really fancy. You see now on the bottom, external events hitting the grid or hitting the database all the time, updating data all the time. You see in combination with search and infinite scrolling, all the green highlighted fields are updated in real time. And this is really a cool web application which has all the features users today expect from such applications. And this is done really out of the box, only using all the features in the Atlas data platform. Okay, that's already it in the end. So I hope you saw some new stuff here, a little bit inspiration. Again, please take your mobile phone out of the pocket, rate this session. That's important for me. And as promised, I will, if you have your phone again in your hand, I wait for 2 or more seconds. I will show you the QR code to a fully detailed YouTube tutorial. It's in German, I must say. Everybody can hear. I'm not a native English speaker, but I did this in German. So, but those of you who don't speak German, you can use the automatic generated YouTube subtitles to see that. So, yeah, fully detailed tutorial available on this under this QR code. And we still have around 5 minutes left for Q&A. If there are questions, I'm very open to that. If not, I will be around the whole afternoon. Please watch out for my gray cap. You will probably see it. And yeah, come by. Let's dig into. Yeah, please.
I'm going to bring the mic.
Microphone,
yeah.
mic.
Let me bring the mic over.
Thank you for the session. My name is Ruslan. Quick question. Is it possible to load the Elasticsearch configuration to the MongoDB Search configuration? Because they look similar. I mean, the index definition.
Sorry, I did get that acoustically.
Is it possible to load Elasticsearch index configuration to MongoDB search configuration, because this mapping of fields look very, very similar?
The last search configuration.
Exactly, to use it in Mongo. I mean, because many solutions already use Elasticsearch for search, right?
Yes.
And this could be a good replacement for that.
Yes, absolutely. So we have lots of Elasticsearch replacements exactly out of that. And if you know Elasticsearch definitions, they look similar.
Yes.
Yes.
This is the question. Is it possible
okay.
to use
translate it? So there is no automatic translation. But if you look at a Elasticsearch configuration and you see the Atlas, so it's really done in no time. Yeah. But there is no automatic magic process to do that. That's still
some work is needed.
Human with brain, yes.
Thank you so much. Thank you.
Thank you.
Thanks for the question. Okay, I see more questions back there. Let me see how I can get there. There was a path before. Has been closed. Okay.
Hi.
Hi.
Question about rules and authorization, and does the search engine consider these rules, so I can't find more data that I'm allowed to see?
Yeah, so the rules engine, so search works outside of the rules engine. You would find more than that, but search gives its results back to the MongoDB. So what search does, it just gives back the document IDs and the meta information, like scoring and highlighting information, back to the MongoDB. And this will look up then the documents inside, and this will walk through the rules engine. Yes.
Okay, great. Thanks.
But the count, the count will hit everything.
Is
yes. To be precise here. Yeah.
Hi.
Hi.
How can I tackle GraphQL mutations?
The mutations?
Yes.
Okay, mutations are done out of the box as well. So I would highly recommend to go to the GraphQL API, just generate a schema, go to the GraphQL, and then you can download the GraphQL schema that you can see out of the box what's available. So mutations are there already.
Can I also do custom mutations?
Yes, of course. You can implement these custom resolvers on any level. On any level.
Okay, and in that resolver code, can I also do like third-party API calls, or what are my capabilities there?
Of course. You have a JavaScript function. It's basically a Node.js, serverless Node.js environment you get. You can use NPM packages. You could use Apollo client or Axios or stuff like that inside your functions. You can implement NPM packages and do whatever you want. You can, call third-party APIs, stuff like that, no problem.
Good, thanks.
Hi.
Hi.
So I know that Atlas Search Index can be tracked through Atlas Console and also through API, right?
Yes, of course.
So is there any other way that DBS can track that through database or some kind of Atlas CLI?
So the question is if you can generate the Atlas Search Index outside of this user interface?
Yes.
Yes. The answer is yes. So what you see in the Atlas user interface is just a visual representation of the Atlas APIs. Okay. There's a huge ton of API calls you can do, and there is one subsection, so Google for Atlas admin APIs, and you will see the documentation. You can create any search index by just using APIs.
For the existing search indexes, do we need any kind of maintenance in when applications are being run? Any kind of rebuilds or kind of things?
Yes, sure. So you can refine your index on the fly. That's important to know. So search will spin up the search index on all 3 nodes. You have a replica set of 3 nodes. It will spin up on all 3 nodes. So there is automatic failover. It has the same availability as your MongoDB as well. And if you refine your index, the old index will stay in place until the new is there, and then you start using the new one.
Thank you.
Great, thank you. We are actually at time now, but as we had it for the last sessions as well, if you have any questions, remember what he looks like. Philip will be walking around the venue all day, basically.
Yeah.
Thank you very much for attending the session. Thank you very much, Philip. Amazing presentation. Perfect timing.
Perfect.
Yeah. Applause.
Thank you so much. Have a nice afternoon. Thank you.